Alright, I hope you are ready to go. This is our first real-life geometry proof that we're going to work on today. And so before we get started, I want to go through a couple of things. Number one is remembering what is a proof exactly. And so I want you to think about it this way. I know you're probably thinking to yourself, when am I ever in my life going to use this? When you get done with this, you're going to be saying that to yourself. So just remember that a proof is what you're trying to do to explain steps. And you're trying to explain why. So you want to think of it like this. You may be thinking, I'll never use this. But no matter what profession you go in, you're going to have to understand a process, let's say, or a pattern. And you may have to teach someone how to do something, or you may have to remember a series like a code or something. So think of it like that, in which all of these proofs are exactly the same, except you have to know the process. So first thing we need to review is segment addition. So hopefully you're sitting there remembering what segment addition is. And if you don't, it's part plus part equals whole. So if you remember, we had a segment, something like this. And we're going to call this segment cuz. And so if I wanted to set up a segment addition equation, CU is your part right here. So I would write CU plus the other part, which is UZ, equals the whole, which is CZ. So part plus part equals whole. So we need to know how to do that in order to do the segment proofs, and then you'll be okay. Okay, so let's get started. Now, all of these segment proofs are going to have 5 steps. No matter what, they're the same 5 steps. The only difference is that your problem is going to be a different picture every time. So what I suggest doing is writing the steps maybe on the left-hand column, which I have in green, and then in the yellow is going to be the actual proof, the problem. So if you want to write that on the right-hand side, that could be helpful. So our problem states that we have this picture here, so I'm going to draw a picture for you. So we have this segment, fun, and we have another segment, love, L-O-V. So in our given, we are given that segment FU, yes, FU, is congruent to LO, and UN is congruent to OV. And what they're asking us to prove is we're going to try to prove that Fn is equal to LV. Now I know you're probably looking at this and saying, duh. It's clear that F to N is the same as L to V. Well, we don't know for sure, we can't assume, so we're going to use what we know about algebra proofs and apply it to a geometry proof. So the first step is going to be for you to mark the parts that they give you. So what's equal in here? And if you remember how you mark parts, you since this is a segment, we're going to use slashes. So since FU is equal to LO, we're going to put 1 slash there. And then since UN is equal to OV, we'll put 2 slashes there. So you always want to mark the parts to start whatever they gave you. This is what they gave you. So you want to mark that every time. It'll be helpful especially when we get to triangle proofs. And then we're going to go ahead and we're going to start our proof. So remember, the S stands for statements. We're going to make a 2-column proof. And the R stands for reasons. So I'm going to leave it like this just because I have a lot to write here, but so you can kind of catch up as you go. So you're always going to start, remember, with the given. So you'll write that FU is congruent to LO and UN is congruent to OV, and the reason is given. So this is your first step. Always, always, always mark what they give you and write down the given. Done and done. 20% over. Okay, let's move on to step 2. Now, as you can see, you don't have to recopy anything. I just rewrote this here for you and show you what we have already. So the second step is you're going to make 2 segment addition statements. So the reason why we're making 2 of them is because we have 2 segments here. We have segment F to N and segment L to V. So first, for step 2, is we're going to put F to n into a segment addition. So hopefully you remember from the last part. So your two parts are going to be fu plus un, and what's the whole equal to? Fn. Okay, so that's that segment. Then we're going to take the bottom segment, which I'm outlining in purple, and we're going to make that into a segment addition. So that would be LO plus OV equals LV. And the reason, again, is going to be segment addition. You can abbreviate it, that's fine. Alright, so far, hopefully this isn't brain surgery. Step 1 is given. Step 2 is you're going to make each of these pictures into a segment addition problem. Alright, step 3. Now here's where we got to think just a little bit. So in step 3, what you're going to do is you are going to use a substitution. Sorry, you can't probably read that very well. Let's change it to yellow. So you're going to use a substitution. And you're going to substitute the given into number 2. So what I always do is I pick the last equation that I made. So we're going to look at this box, the yellow right here that I starred. So let's look at LO to start. So LO, if we look at the given and we come back up here, what is LO equal to? Hopefully you're saying to yourself, LO is equal to FU. So instead of LO, I'm going to write FU. I'm taking it and I'm replacing it. So just replacing the LO with the FU. Alright, now let's look at the OV. Okay, again, if we go back to the given, what is OV equal to? OV is equal to UN. So I'm going to, instead of writing OV, I'm going to replace the OV with UN. I'm making a substitution here. So obviously this is going to be substitution as your reason. Okay, now LV, we do not know anything about LV. If you look at the given, they say nothing about LV. So you can't assume anything. Even though I know that the problem says we're trying to prove that Fn is equal to LV, we haven't proved it yet, so you can't use it. So we're just going to drop down the LV. Alright, so you've just done a substitution. Let's look at the next step. Step number 4. Okay, so again, this is what you should have written down so far. Now let's see, I think you're amazing and you're going to figure this out. So what you have to do now for this next and last most difficult thing is you're not going to look at the equation used before. So kind of just take that out of your mind right now. And we're looking at the one we didn't substitute and our new equation. Do you see anything exciting about these two? The one we didn't substitute and the new substitution equation. Hopefully you're saying to yourself, ding, 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 ding. Whoa now. This and this is the exact same thing. So what property is that? Where if this is equal to Fn and it's equal to LV, what does that mean? That means we could equal it to itself. So it's kind of like, remember the property that said, we said, well, if Mesmer beat King and King beat Riverside, then Mesmer should be able to beat Riverside. That's transitive. So our fourth step is we're going to use the transitive. And we're going to show that, hey, we use substitution and now Fn is equal to LV because of the transitive property. So the fourth step is transitive. So you're going to use a transitive statement in the last one. Alright, I know you're probably mind blown right now. Don't worry, we're going to practice this more. Let's look at the last step, which is a little bit crazy and I do believe is a force, but I got to show you because you never know. If you go and be a geometer someday, you may need this. So the fifth step is this. If you noticed throughout this whole proof, did you see that I never, ever, ever used a segment bar or the congruent symbol, ever? And that's okay, that's perfectly legal. But the problem is that these are segments and they are congruent. So the fifth step is you are going to take and you're going to add the bar back on and the congruent symbol. So the last step is you're going to add the bar back onto Fn and make it congruent to LV. So all you're doing is just making the correct, proper notation. And this is called the definition of congruent segments. And I abbreviated that, so if you need to fix that. So 5 is the definition of congruent segments. So again, all I'm doing is I'm taking the letters and I'm putting the bar back on and putting the congruent symbol on. So this is exactly what we're trying to prove. Whew. Okay, I know you're probably like, whoa, this is cray-cray. I don't even know what's going on. But all I can say is this. At least you did not have to wear this for Christmas, as this is baby Jordy, and she had to wear this. So at least you didn't have to wear this, but hey, now you know. Hopefully you're not going to go crazy.